Good afternoon. In part 1, we covered basically the first step in the SketchUp project stages. That was, we showed you a completed model that was frozen, and we gave you a tour of CutList Bridge LX, and you got to see what its capabilities are. In this part 2, we're going to go to step 2 of the project stages, and that is to show you how to assign CutList Bridge LX attributes to a component. Indeed, we will assign attributes to all components in the model, and we'll use the extended entity info to do that, and we'll cover the extended entity info in some detail. We will also show you how to create the reports you will need for your model. So with that, let's start with a piece of furniture. This shaker tall clock is a good piece to begin with because in addition to learning how to add attributes to components, this piece points out why it's important to think about component naming and layer naming. Let's look at the model. Tall clocks like this can usually be broken up into what I would call obvious sub-assemblies. In this tall clock, the feet might be one subassembly, and then the base, and then the waist, and then the hood. And that's what I've done here. If you'll notice my layers, this is all of the on-dimensioned layers in the model. There's a fair number of them. Notice that the base, this part here, all of the parts associated with the base begin with all of the layers associated, and I should say tags with the new terminology. All of the tags associated with the base begin with the word base. All of the tags or layers associated with the feet begin with the word feet. All of the parts and layers associated with the hood begin with the word hood. And lastly, the waist parts and layers begin with the word waist. Now, I try to carry this through to the parts themselves, though it's not always convenient. But for instance, if I look at this part here, that's the waist door. And this part is the waist sides. This is the hood column. It gets tricky sometimes, and you can't always do this. For instance, this part here, it would be tough to call this the front feet. It's actually a front foot. So in my naming, I called it a foot. Now the reason for doing this is that it helps to collect parts in a way that allow you to easily highlight them so that you can add attributes. Now what I'm going to do is I'm going to begin adding attributes to the entire part. In other words, this clock primarily is cherry hardwood. Not every single part is cherry hardwood, although every part turns out to be hardwood. So what I can do is I can select all. Open up the extended entity info. And notice nothing appears in any of these attributes. What I'm going to do is I'm going to select material type, rough lumber, and material name, cherry. Now I'm going to deselect all of this and randomly look at a few parts. Notice that's rough lumber cherry. 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 All the parts in this model right at the moment have material type rough lumber and material name cherry. Now, a lot of the parts in this model are not going to be cherry. For instance, this back is going to be something else. But we don't want to go to every single part in the model and set the attributes. What we want to do is be smart about it. So here's what I'm going to do next. I'm going to clear all the tags or all the layers. And I'm going to go into things that I want to be something other than cherry. So I'll choose the back, base blocking, the base bottom, base dust panel, the base feet, splines, the hood base, the hood base blocking, oops. Okay, I believe I've got all of the layers chosen for all of the parts that you won't see and will be some other type of material. So I'm going to select all of this. And I'm going to select again rough lumber. By the way, you may have to select a different material for a moment and then come back to rough lumber to get this name drop down to appear. That's just a function of the way HTML works. So I'm going to pick birch. That's what I use for the secondary wood in this design. So I'll pick birch. Okay. Now, I don't know if I've missed any. I may have. And if I did, I'll find them later. So what I'm going to do now is clear everything, and I'm going to go one layer at a time. I'm going to look at the back, and that's correct. Blocking, that's correct. Those pieces are correct. The bottom, you don't see this. The base cove molding is cherry. We want to make sure that's cherry. Now I'm going to do all this offline and check these, and I'll be back. Okay, I've checked all of the materials and they look right. So that was pretty simple. Now, what I want to do is just explain each of these attributes. The first thing I should mention is the component number is not an attribute. That is added by CutList Bridge LX. When you create a cut list, it will go through and it will assign part numbers either numerically or alphabetically depending on what you choose. So that's not something you can assign. Subassembly is something you can assign. For instance, what I could do is choose all of the base parts and put the subassembly base in here, all of the feet parts, and put the subassembly feet, all of the hood, put the subassembly hood in there, and all of the waist. And I'm going to do that in a second, but let me go on. There's a column for tags. Tags are things like little notes, like grain matching. For instance, suppose you wanted to match the grain on this part and this part. This part. That is, suppose you wanted to cut those from the same piece of material and match the grains here. Or this is actually a better example. Suppose you wanted to match the grains here. Well, what you could do is for this part, you could put, for this and this part, select them both, and put in here something like GM1 for grain match 1. And that would tell you on the cut list that those two parts had to be grain matched and that they were a pair. So that's what tags are for, little notes like that. Info can be used in two ways. If you're designing cabinets or something like that, you might want to cut out parts and oversize certain parts on the initial cut. In which case, you can assign things like W, L, T for oversized in width, length, and thickness. And I'll show you some examples of that later. You can put notes in here. The notes aren't terribly useful because, first of all, CutList Bridge LX doesn't provide a lot of capability for examining those notes. I'll show you how it does do it, but the options for examining those notes are not well designed right at the moment. On the other hand, CutList Plus FX does allow you to look at those notes more readily. Now that's sort of common attributes. And like I say, component part number is not really an attribute. Now you have to decide whether this is a milled part or it's some other type of part. Milled parts are parts you want cut lists for because you're going to cut them in your shop. So most of the parts, in fact all of the parts that I've shown in this model for this clock are milled parts. We've assigned them as hardwood or rough lumber and material type either cherry or birch. Some parts might be sheet goods, in which case an edge has to be banded. You can put a code in here for which edges get banded. Normally a cut list will use the longest dimension as the length. However, there are times when you don't want that to be the case. And typically that's true in cabinet parts. Things like kitchen cabinets or something like that. For instance, the bottom of a kitchen cabinet might be more narrow than it is deep. And therefore, the grain direction runs from left to right as you're looking at the cabinet. And therefore, you want the narrow direction to be the length. So you have a number of methods for assigning the short dimension as the length. One is to simply say for that part, swap length and width. Another is to let this cabinet mode, resize mode, do it for you automatically by enabling auto swap. And that will depend, based on rules for cabinet making, it will choose the correct dimension for the length. However, to do that, you're going to have to assign what the part is, whether it's a back, a bottom, a shelf, a side, a top, a custom part, a draw front, a draw back, a draw side, or a draw bottom. So if it knows those things, then it can correctly assign the grain direction. That is, the length will be whatever dimension it needs to be to get the grain correct. Now, you may also want to resize parts. And that means have an initial cut that is different than the final cut. And you may want to do it in thickness, in width, or length. And so you can choose cabinet mode or resize mode and put in dimensions. So for instance, if you want the initial cut for this side to be 3/4 of an inch longer than the final cut, you can put that in the length here. Other items, if I choose other items, it can't be a milled part and vice versa. And so other items, you can type in the type of item. All right, now those are the basic attributes that you can assign parts. In this model here, we're not going to use too many of them. But let's see which ones we are going to use. What I want to do is take everything that belongs to the feet. Well, no, let me start by grouping visible layers. So let's clear all layers, and I'll choose the back. It's actually its own subassembly. So I'm going to put a subassembly of back in here. There's only one part that belongs to that subassembly. And now I'm going to choose all the base layers. And I'll select them all, and I'll put the subassembly base here. Now I'm going to clear all layers again, and I'm going to choose just the feet layers. That helps me assign the subassembly feet to that. I'll clear all layers again, and now I'll go to hood. Everything that has a hood, and there's a lot of them. I'll do Control A, and I'll assign the subassembly hood to those parts. And lastly, I'll choose the waist. Whoops. Let me clear all parts first. And I'll select all those parts, and I'll give them a subassembly waste. All right, so now let me go back to the full model. I can now randomly choose a part, and I know that that belongs to the waste subassembly. I can choose this part, and I know it belongs to the base subassembly. I can choose this part and know that it belongs to the feet subassembly. And lastly, choose this part and I know it belongs to the hood subassembly. Now those are pretty much the useful attributes for this particular model. Now I could, and I'll do that. The front door is going to be cut on a shaper. And anytime you use shapers or routers, you want to allow for a little extra material. So what I'm going to do here is we're going to choose that part, and I'm going to say use the resize mode, and I'll resize it by width and length by a 1/2 inch. So anytime I look at that part, I know it's going to be a 1/2 inch bigger. I'm just going to oversize just that one part. In cabinet making, you'll find that we oversize a lot of parts. And so that'll be, this cabinet resize mode will be used a lot. Okay, so now what I want to do is create my cut list. But before I do, I have to go to the Setup tab and make sure everything is set up the way I want it. I'm going to leave Legacy Mode unchecked. Legacy Mode would be checked if you have an older version of CutList Plus FX and you were going to export your CutList to CutList Plus FX. Newer versions of CutList Plus FX don't require this. In fact, make sure it's not checked for newer versions. The component numbering, I have a choice. I can either do it myself and put component numbers in there just like any other attribute, or I can let CutList Bridge do it, which I'm going to do. I'm going to let CutList Bridge do that. And I'm going to let it assign numerical numbers, 1 through whatever. I could also use alphabetic, but I'm going to use numerical for this case. I have 3 styles of information that I can put in the Info tab, or the Info input. I'm going to use the one that just provides a letter for the dimension that is oversized. For instance, if I oversize something in the width and length dimension, it will put just a W and L in the info column. If I oversize in all 3 dimensions, it'll put a W, L, T. If I oversize in just one dimension, like thickness, there will just be a T. If I were to select this, I'd get the same WLT, but next to the W, it would tell me whether I oversized it, if this were a plus number, or undersized it, if this were a negative number. And if I choose this, it will tell me the actual oversizing, the actual dimension after oversizing. Now, the description, I can also hide some stuff in it. I can either just tell you what the part is, or I can tell you what the part is and the part type. I almost never use this, but if you want to know the part type, then, which is kind of interesting for cabinet designs. So if you want to know something is a shelf, it'll give you the name of the part and then the type of part. For instance, this is a left side and it's a side type of part. But I usually use this. I can also assign the subassemblies myself, like I did in this model, or I could have the subassemblies take on the name of the layer. And again, this is something that I almost never use, but it could be useful in some types of models. That is, the subassembly name would be the name of the layer that it's on. So if I wanted to put an entire subassembly on a layer, then I could automatically name the subassemblies by just choosing this option. But these are the options that I'm going to choose. So now I can close this and go to CutList Bridge, CutList Bridge LX Reports. So my project name is Shaker Tall Clock. My customer name is me, Jose. I'm going to use CSV files that are delimited by a comma. Now in some European countries, the comma is used as a decimal point. And so you may want to delimit this either with a tab or a semicolon. But for most projects, this will be comma. I'm going to produce two types of cut lists. One is just a CSV file that can be opened with any spreadsheet. For instance, Excel, OpenOffice Calc, Mac numbers. Those will all open up this kind of file. I'm also going to create a .cwx file that can be opened in CutList Plus FX. And I'll show you that a little later. And now there's a number of ways I can produce these reports. I can either, at the beginning of producing reports, I could choose just some number of parts and using the selection tool. And then choose by selection. And I'd have to choose by selection for all of them. Or I could create a number of scenes and have different parts and different scenes. And for each of these reports, I could choose a scene. In this case, I'm going to choose perspective for all of these. Now here's one important thing you want to remember. The cut list, whether you do this by selection or whether you do it by a scene, the cut list has to have either a scene or a selection that has all of the parts that you want in any of the reports. In other words, all of the reports get their information from the cut list. So if you're missing some parts in the cut list for any of the reports, you will not get a complete report. So in this case, I'm going to use the perspective scene for all of these. Now, I'm not going to explain labeling here at the moment. We'll come back to that. But suffice it to say, this is the composer for labels. And here I can choose the format that I want for my rough end dimension lumber labels. But I'll come back to that. So now I'm ready to say create reports. And they're created. Before you click OK on this dialog box, make sure that you read this so you know where it placed the documentation. In this case, it placed it in my user directory on my desktop in a folder called Shaker Tall Clock. So I'll say OK. And I'll bring that folder in. This is the Shaker Tall Clock folder that's on my desktop with my username. So there are 4 files here. The first one is the dimensioned lumber schedule, and it's a comma separated value file. Any CSV file and a CWX file, for that matter, can be opened in a spreadsheet calculator. And we're going to use OpenOffice Calc in this video. Now, I don't have any dimension lumber in this model, so this report will be pretty much blank, but I'll open it anyway. Likewise, I have a rough lumber report, also a CSV file, and that's the one that's most interesting to me. And I also have a cut list in CSV format, as well as a cut list in CWX format for opening in CutList Plus FX. So let's start from the top and work down. As I promised, we don't have any dimension lumber in this project, so I get pretty much a blank report. So let me close that. And let me open up the rough lumber schedule. Okay, so now this is the rough lumber schedule. And notice that it's got 2 sections, a rip cut section and a cross cut section. And I'll explain those in a second. There's also some information up here, project name, customer name, and a timestamp, so you can keep track of when were these produced. So what it does, it takes each type of rough lumber. Well, rough lumber is the type, but it takes each species name of rough lumber, and it tells you what you need in terms of thickness and width. And it'll work down from the largest to the smallest. So for instance, it tells me that I need some cherry, which is 1 3/32 by 1 3/32. And I need 2 of those, 2 feet of those, 2 linear feet of those. Now we'll examine some of this to see what this means. And then it'll tell me I need 1 inch thick by 3 inches, 3 1/4 inches wide, and I need 4 linear feet of that. So on and so forth. The most interesting and most common will be 3/4 inch thick by a certain dimension wide, and it'll tell you how many linear feet you need of each. And it'll go all the way down to, after birch, it'll go down here and tell you of each type how many board feet you need for each thickness. So for instance, for the birch, I need 14 board feet of 4/4 birch. I need 1 board foot of 5/4 and 3 board feet of 6/4 birch, and 2 board feet of 8/4. And then it'll give you the cherry. After the rip cuts, so what you're doing here is you're taking 3/4 inch material, for instance in this case, and you're ripping it 9 7/16 inches wide, and you need 5 linear feet of that. So this is your rip schedule. And after you've completed your rip schedule, you're going to cross-cut things. And now what you're doing is cross-cutting. Let's take the 3/4 inch stuff. you're going to cross cut some stuff that's 3/4 of an inch thick by 18 inches wide by 19 1/8 inch long. You need one of those. So on and so forth. And it'll tell you in each case, for each thickness, width, and length, how many of them you need. Here's one where you have a group of 3/4 inch thick pieces by the same width, but you need different lengths, and it'll tell you how many of each that you need. So that's your crosscut schedule. Now, let's take a look at the remaining CutList files. We'll start with the CSV file first, and then we'll go to the CWX file. So this is the cut list. It's broken down into rough lumber and any sheet goods. If there were sheet goods, would be here, and then any other items, if there were other items, they would be here. But let's take a look at this. Notice in this column you've got numbers 1 through I'm not sure how many. Looks like perhaps 49. Parts, sequentially numbered. And then the subassembly. Notice that the subassembly is hood, waist, feet, hood, waist, feet, base. Notice this one is missing. And I think as I was doing it, I think that I forgot to select the back before assigning a subassembly, but we can go back and fix that. Not a problem. This tells you the part name. This is actually the name of the component, the number of those pieces you need, the initial cuts, thickness, width, and length. And in this case, the initial cuts will be the same as the final cuts over here, final thickness, final width, final length, with the exception of one part. See this W and L right here under the info column? What that tells me is that this was resized in width and length. And if you remember, we resized it by 1/2 inch. So if I look at the width and length, let me highlight this. If I look at the width, it's 8 1/4. But if I look at the final width, it's 7 3/4. Notice the 1/2 inch difference. So that was the width being resized by plus 1/2 inch. The same is true here. This will be 1/2 inch larger than the final dimension, which will be 28 7/8. If I did my arithmetic. Oh yeah, there it is. 28 7/8. So that's the difference between these two columns. Now I'll explain this one. Dec T, Dec W, Dec L. That means decimal thickness, decimal width, and decimal length. These are here simply because if you want to create some equations that manipulate these dimensions, they could be any kind of equation you want. For instance, suppose you wanted to calculate the weight of a piece of furniture. Well, you might know the weight of a board foot, or the weight of a cubic foot, or something of cherry, or the cubic foot of birch. Well, using these numbers, you can calculate the volume of all of this and multiply it by the weight per cubic foot, and come up and add it all up and come up with the weight of this piece of furniture. But that's why these are here, so that you can create your own equations in Excel to figure out whatever it is you want to figure out. So the next one is the material itself. And notice that we have birch and cherry all the way down. It's either birch or cherry. Now this is an interesting one. Can rotate. Typically, you want the longest dimension of a part to be the length, because that's the dimension the grain runs in. But sometimes parts are different. Sometimes you want the grain to run in the direction of the shortest dimension. Not the thickness, but the shorter of the two, width and length. And so what you can do is tell CutList Bridge to rotate that particular part so that the optimizer, if it were sheet good, for instance, would put the grain in the direction of the short dimension. Also, if you have sheet materials, you often have to band the edges. So you can put some information in here about banding. Also, you can put some information here in the notes field. Now, we'll look at this can rotate and banding more closely when we get to cabinet designs instead of furniture designs. You'll see that this becomes much more useful. And also this info column will become much more useful. Lastly, there is a tags column. I didn't put anything in the tags column, but if you remember, what I said to you is you could put things in the tags column like, you know, these two pieces get grain matched. So you might put grain match 1 in one piece and grain match 2 for 2 other pieces, so on and so forth. So that would show up here. Okay, so that's your basic cut list. Let me get rid of that. And let's now look at what happens if you open this up in CutList Plus FX. Here's the same cut list opened up in CutList Plus FX. And again, notice, by the way, that we're missing a subassembly here. This is exactly the same cut list. One nice thing about this application is that it's easy. While you can sort things in a spreadsheet, it's much easier to sort things here. If I wanted to sort by part number, I could click that. Now, unfortunately, it doesn't actually sort correctly by part number. What you get is anything that starts with 1, which includes the teens, and then things that start with 2, which includes the 20s, and then things that start with 3, which includes the 30s, so on and so forth. It'd be nice if the algorithm actually sorted this as integers, but it doesn't. You can sort the subassembly, and now you got all the base subassembly parts right here, all the feet subassembly parts right here, all of the hood here, and down here the waist. You can sort by dimension if you want, material type, material name. Now you get all the birch material here. so on and so forth. The nice part about CutList Plus FX is the ability to create optimized layouts, but we'll demonstrate that when we have a project with sheet goods. For now, we don't, so let's just leave this. Okay, now those are the 4 files that are produced for the various types of reports in CutList, but you can get the CutList in another form. If I go back to CutList Plus FX, I have 3 other commands that I can use once I've used this command. I have to use this command first to generate the cut list. Once I've done that, there's 3 other commands I can use. One is to optimize the sheet goods. Now, this project has no sheet goods, so I can't use this right now. You'll see it later when we discuss cabinets. But let's look at the rough lumber cut list. I'll bring that in here. Notice you get this cut list, which is, again, a spreadsheet. And it will give you all of the information that you get from the cut list, but in a nice looking printable layout. For instance, if I want to print preview, that's what it'll look like when I print it out on a piece of paper. And in order to print it out, I can just say print. And maybe I want to print it to a file like a PDF. I can do that. Just say print. After selecting Microsoft Print to PDF, I can say print and it'll save it in a PDF file, and I can print it at a later date. That was the rough lumber. We have no dimensioned lumber in this project, so we can't look at that. But I just wanted to demonstrate that you do get a native cut list that can be printed either on paper or to a file. All right. Now we've covered a lot of material here. Almost all of it was focused on the extended entity info and assigning attributes. We covered the setup a little bit, but basically what we did was discuss how you assign attributes. And we've also shown you some simple strategies for assigning attributes such that you didn't have to assign them one part at a time. Remember, this model has 49 parts. If you try to assigning these attributes to each part one part at a time, that would take you a very long time. But by using the strategies we used, that is, by naming the tags or layers with names that started off with the subassembly name, as we have here, base, feet, hood, waist, we made it easy to assign subassemblies. We also used the select all, in this case, to assign everything a rough lumber, and even assigned everything cherry initially, and then we sought out the parts by layer that were going to be birch, and then we went back and changed those to birch. And then we went and put in other things like parts where we're going to resize by a ½ inch. So these strategies of creating scenes, creating tags that have names that make sense, that might start with subassembly words, and then the description of the types of parts on that tag or that layer. That's very helpful in making sure you don't have to assign attributes one part at a time. And it makes assigning attributes really quick and easy. Now, one of the things we did not cover is some of the rules for using CutList Bridge, and I want to cover those right now while we have a few minutes. There are a few simple rules for using CutList Bridge LX that you must follow, and I just want to go through them quickly. The most important one is that all model parts must be a component. They cannot be a group. CutList Bridge LX does not support groups. Do not use them in your model. Next, there must be no nested components. The idea of nesting components to form things like subassemblies can be done much better using things like scenes and layers. And I highly encourage you do that. Do not nest components. CutList Bridge LX does not support nested components. Third, attributes are assigned to a component. That means that any instance of that component will have the same attributes. Attributes are component attributes, not instance attributes. Lastly, make any changes you want to make to a component's attribute. Do it in SketchUp using the Extended Entity Info dialog box. Do not try to make those changes somewhere else. With that, I think we're finished with this part 2. And so, until part 3, have a good day.